Imagine taking a pot of boiling water and sealing it with a 60-kilometer thick lid of solid granite.
Just completely welding it shut.
Right, exactly. And then you leave it on a roaring stove for, like, 500 million years.
Which is just a terrifying kitchen nightmare.
Oh, totally. But according to this radically controversial new scientific framework we're looking at today, you aren't just making a bomb, you are looking at the exact thermodynamic history of planet Earth.
Yeah, and the inevitable explosion of that planetary pressure cooker, it's not just a story about rocks. I mean, it's an attempt to rewrite the entire foundation of how we understand physics, biology, and honestly, how we teach science to the next generation.
Right. So welcome to the Deep Dive. Today we are unpacking a highly alternative, totally disruptive framework by an author named Arndt Michael Meyer.
We're looking at a two-part proposal here. First, there's the small bang theory, which is this complete reimagining of Earth's timeline.
And second, there's a new research methodology he calls the modern AI bibliography.
Exactly. Our mission today is to explore how this author claims we can basically shatter the isolated silos of modern science.
These pseudo-knowledge silos, right.
Right. He argues that what we currently accept as scientific fact is actually a patchwork of pseudo-knowledge. And he's proposing a unified model that completely changes the cognitive burden we place on students and researchers.
But before we get any further, we need to set a really clear boundary for you, Felicity.
Yes, very important.
The material we're exploring today presents a paradigm that directly, and I mean aggressively, challenges established geology, cosmology, biology.
It throws foundational concepts like plate tectonics and fossil fuels completely out the window.
Out the window, right. So as your guides on this deep dive, we are not taking sides. We are not endorsing these viewpoints as the new absolute truth.
And we aren't mocking them either.
No, not at all. We're acting as forensic explorers. We're unpacking this intellectual architecture so you can understand the mechanics of the theory, how he built it using AI, and what it means for the future of education.
We are just dissecting the logic. So we'll start with the author's really severe diagnosis of the current academic establishment, this crisis of pseudo-knowledge silos.
And then we'll get into the actual physics and the timeline of the small bang theory itself.
Right, and the massive mindset shift this demands from learners, moving away from just memorizing mysteries to applying pure logic.
Then we'll look at how Meyer used artificial intelligence to bypass traditional peer review.
And finally, his strategy for actually forcing these ideas into university textbooks.
So let's start with the problem. Meyer looks at the current state of science, and he sees a broken machine. He talks about a crisis of pseudo-knowledge silos.
Yeah.
And when I first read that in the source material, I thought, okay, he's critiquing university bureaucracy. But he means something much deeper, doesn't he?
He means a full-blown epistemological crisis. His core argument is that modern scientific disciplines, so geology, biology, astronomy, they've just walled themselves off from one another.
Right, they're operating in total isolation.
Exactly. And because they don't have to perfectly align with the logic of the other disciplines, they develop this pseudo-knowledge.
I can kind of see how that happens. I mean, you have a geologist trying to solve a problem with tectonic plates and a paleontologist trying to solve a problem with dinosaur fossils.
And they aren't necessarily checking to see if their solutions contradict each other's fundamental physics.
Right, which leads to what Meyer calls the fairy tale problem.
Yeah, so he argues that when an observation pops up that completely defies the established model of a specific silo, the scientific establishment doesn't throw out the model.
You just patch it.
Right. They invent a highly complex, almost magical patch to explain away the anomaly so they don't have to rethink the core theory.
And the prime example he targets in the text is subduction.
Oh yeah, he goes hard after subduction.
For anyone who hasn't taken geology recently, subduction is the widely accepted mechanism where tectonic plates crash into each other, and one plate gets pushed deep down into the Earth's mantle and melts.
And Meyer absolutely refuses to accept this.
Why? I mean, it's in every textbook.
He rejects it entirely based on physical mechanics. He argues that trying to push a lighter, rigid crustal plate down into a denser, highly pressurized molten mantle violates basic physics.
Because of the density differences.
Right. He says it's like trying to push a massive block of styrofoam deep into a pool of dense liquid mercury. The buoyancy and pressure dynamics just don't allow it.
But the established geological silo kind of needs subduction to exist,
And
right?
they absolutely need it because the Earth is creating new crust at the volcanic ridges in the middle of the oceans, but the Earth itself isn't getting any bigger.
An old crust has to go somewhere.
Exactly. The standard model requires a disposal mechanism.
So according to Meyer, Science invents the fairy tale of subduction to balance the equation.
Rather than asking the much more terrifying question, which is what if the Earth's radius hasn't always been constant?
Wow. Which brings up a fascinating psychological question. If a theory requires so many complex workarounds, why do these patches survive? Why don't scientists just hit the reset button?
The author points out three massive hurdles. The first one being social and cognitive inertia.
So human nature.
Basically, it's the protection of status. Imagine a tenured professor who has spent 40 years publishing papers, attending conferences, building their entire identity around the intricacies of plate tectonics.
And then someone comes along and says it's all wrong.
Right. To suddenly entertain a unified theory that renders all of that work obsolete, it's cognitively devastating. There is a massive disincentive to dismantle the foundation your authority rests on.
And that's tied closely to the economic reality, right?
Well,
Funding.
absolutely. The grant system is designed to reward incremental progress within an existing paradigm.
Right. If you write a grant proposal saying, I want to study the composition of the mantle, you get funding.
But if you write a grant saying, I want to prove the entire foundation of geology is wrong.
They throw your application in the trash.
Exactly. Which culminates in the sunk cost fallacy on an institutional scale.
Because governments, universities, textbook publishers, they've invested billions of dollars in decades of pedagogy into these standard models.
To admit that the overarching architecture is fundamentally flawed feels like an unacceptable loss of investment. Meyer literally calls it throwing good money after bad.
Just patching a sinking ship rather than building a new one.
Yeah.
But let's bring this down to the ground level, to the perspective of you, the listener. If the academic establishment is trapped in this cycle of patching contradictory silos, what does that actually do to a student sitting in a classroom?
It's devastating for education. According to the text, it forces students into rote memorization of over 100 separate mysteries.
Because nothing connects.
Right. The curriculum becomes just a list of anomalies that students have to accept as unexplained phenomena.
The text highlights a few really glaring examples of this, like biology and aerodynamics.
Well, the pterosaurs.
Yeah. Why did massive pterosaurs like Quetzalcoatlus have these wingspans that under our current atmospheric pressure shouldn't have been able to generate enough lift to get off the ground?
And physics. The Earth's rotational energy is currently too high when you calculate the angular momentum from the dust cloud that supposedly formed it.
Or planetary science. This one is huge. The isotopic signatures of Earth rock and Moon rock are virtually identical.
Right, and the standard giant impact hypothesis says a foreign Mars-sized body named Theia hit Earth, and the debris formed the moon.
But statistically, it's incredibly improbable that an alien body from another part of the solar system would have the exact same chemical makeup as Earth.
But the current educational model basically tells the student, hey, don't worry about the contradiction.
Just memorize the Theia impact for the test.
Exactly. Except that the matching isotopes are a quirky mystery. We are actively teaching students that being wrong, or at least accepting unexplainable contradictions, is the natural state of science.
It breeds this terrible sense of learned helplessness.
Meyer argues we've internalized the idea that the universe is just too complicated, too chaotic to make total logical sense.
And the cognitive burden on the student is immense. They aren't learning a connected system, they're just memorizing an encyclopedia of fragmented exceptions.
Which kills curiosity.
Totally. Because if every path of inquiry ends with a professor shrugging and saying, well, it's an anomaly, why would you keep asking questions?
That is the exact educational crisis Meyer is trying to solve. He believes that if you strip away the silos, everything can be logically deduced from a single, unified starting point.
Which brings us to the small bang theory itself. Let's dive into the actual mechanics of this alternative timeline.
Okay, so Meyer starts us off 4.5 billion years ago. And for the vast majority of Earth's history, he claims things were remarkably quiet.
He calls it a quiet and linear formation.
Right. For billions of years, the Earth cooled from a molten state and slowly formed a structure. But then, by 541 million years ago, a critical threshold was reached.
The Earth became completely sealed by a solid, unbroken granite crust.
A completely sealed vault. The text notes this crust was roughly 20 to 60 kilometers thick, and it covered the entire globe.
No tectonic plates, no puzzle pieces, just a solid, seamless sphere of rock.
Exactly. And this initiates what we can call the pressure cooker phase, which lasts from 541 million years ago, right up until 66 million years ago.
So inside this granite vault, you have this churning, superheated mantle.
And the magma is releasing immense amounts of trapped gases, water vapor, carbon dioxide, methane.
Now, in the standard model, volcanoes vent that pressure.
But in Meyer's model, the 60-kilometer granite shell is too strong. The gases cannot escape,
They're just trapped beneath the crust.
building massive, continuous internal pressure over nearly 500 million years.
The thermodynamics of that are staggering. The entire interior of the planet is trying to expand, pushing against an unyielding stone lid.
And the surface of this planet looked absolutely nothing like the globe sitting in a modern classroom.
It was an entirely different world.
According to the text, the Earth's radius was about 6,410 kilometers, which is roughly 40 kilometers smaller than it is today.
And because the crust was unbroken, there were no deep ocean basins, right?
Right. Water just existed in shallow, planet-wide swamps,
And the axis was perfectly upright. Zero axial tilt.
which means no seasons. The climate was totally homogeneous, a perpetual, humid greenhouse across the entire globe.
And crucially, no moon in the sky.
No moon. So you have this smaller, completely enclosed, upright, swampy planet building up apocalyptic internal pressure. For 500 million years, the boiler is heating up.
And then we hit 66 million years ago.
The small bang, the internal pressure finally exceeded the tensile strength of the granite shell.
The crust didn't just crack, it burst.
The Earth ruptured violently from the inside out, rapidly expanding to its current radius.
The visual of that is terrifying. Just the entire surface of the planet shattering like a glass ornament.
And this single cataclysmic explosion is the cornerstone of Meyer's attempt to simplify the curriculum. He uses this one thermodynamic failure to explain almost every major mystery in Earth's history.
Okay, let's test this logic against the anomalies we discussed earlier. Let's start with the moon.
Okay, so in the small bang framework, the explosion was so violent that it ejected material from the Earth's crust and upper mantle directly into space.
The text calculates this as roughly 1.23 to 2% of Earth's total mass.
Right. This debris blasted into orbit, aggregated through gravity, and formed the moon.
Which instantly solves the isotope mystery.
Exactly. You don't need a magical, identical alien planet hitting us. The moon's rock matches Earth's rock perfectly because the moon is literally made of Earth's shattered prehistoric crust.
It's a direct physical deduction.
No fairy tales required.
But wait, getting 2% of a planet's mass into orbit requires unbelievable force. How does the theory account for the physics of escape velocity? Wouldn't the debris just fall back down?
So Meyer attributes it to the compounding nature of the pressure cooker. It wasn't just physical rock pushing against rock.
Right, it was the gases.
Yes. 500 million years of highly compressed, superheated gases acting as a propellant. When the crust finally gave way, the sudden decompression of those trapped volatiles created an explosive outgassing event.
Like popping the cork on a champagne bottle that's been shaken for a million years.
Exactly. Powerful enough to launch the lighter, uppermost layers of the crust beyond the pull of Earth's immediate gravity well.
That outgassing brings up the next anomaly, the deep oceans. If the Earth was just a shallow swamp before, where did the Pacific Ocean come from?
It was literally sweated out of the mantle.
Sweated out, yeah.
All that trapped water vapor that contributed to the explosion was violently released into the atmosphere. As the crust shattered, the pieces of granite, which are our current continents, were pushed apart by the expanding radius.
Oh, and that exposed the denser, lower basalt layer of the Earth beneath them.
Right, creating deep, empty basins between the continents.
And then the water filled them.
Yes. The released water vapor condensed, aided by a literal rain of ice falling back down from the initial spacebound ejecta, and flooded these newly exposed lower elevation basalt plains.
So the deep oceans were born in the immediate aftermath of the rupture.
And the seasons. You asked about the seasons.
Right, the 23-degree tilt.
The rupture wasn't a perfectly symmetrical balloon popping. It was asymmetric, likely weaker on one hemisphere than the other.
So the sheer kinetic force of this uneven explosion physically tilted the Earth's rotational axis.
Exactly. That sudden, violent tilt instantly created the seasons we experience today.
And of course, the date itself, 66 million years ago.
Yeah.
You don't need a paleontology degree to know what happened then.
The Cretaceous-Paleogene mass extinction, the death of the dinosaurs.
Standard science points to a massive asteroid impact at Chicxulub in Mexico.
But Meyer's theory argues that the small bang was the extinction event.
Which makes sense. An expanding planet, a shattered crust, hypercanes of outgassing water, a sudden shift in atmospheric density.
And a violently tilting axis. That is an environmental apocalypse that perfectly accounts for the sudden end of the dinosaurs.
It even explains the pterosaurs.
Oh, the wingspans. Yes.
Right. If the Earth was smaller and holding a much denser atmosphere beneath that unbroken canopy, the air pressure would have been significantly higher.
And in a thicker atmosphere, the stubby wings of a giant pterosaur suddenly make perfect aerodynamic sense.
The beauty of this framework, purely from a pedagogical standpoint, is how it collapses geology, biology, and physics into one deducible narrative.
It really does. The continents aren't mysterious puzzle pieces drifting randomly on convection currents. They are the actual shattered fragments of the original smaller granite shell.
Resting on a newly exposed basalt floor.
And think about fault lines and earthquakes.
Oh, right. Because of the geometry.
Exactly.
Yeah.
If you take a curved piece of hard granite that formed on a planet with a 6,410-kilometer radius, and you force it to rest on a planet that is now expanded to a 6,450-kilometer radius,
The geometry doesn't fit. The curvature of the continent is too tight for the new, larger ball.
so the edges will constantly grind, settle, and snap as gravity tries to flatten that smaller curve against the larger sphere.
That geometric tension explains earthquakes and tectonic stress without ever needing the fairy tale of subduction.
It's all just deductive reasoning.
Which brings us to this profound mindset shift for the learner. If a student accepts this framework, they undergo a complete cognitive rewiring.
They step out of the silos.
They move from a world of passive memorization of 100 random mysteries to active logical deduction.
The text introduces an overarching philosophical framework for this called NKE.
Nix Christa et was. Nothing crusts something.
Right. Myers suggests that the Earth's small bang isn't a freak anomaly. It is a local expression of a universal mechanism.
So a fractal of how the whole universe operates.
Exactly. The formation of matter, planets, moons, it all follows this predictable cycle of containment, pressure, and rupture. To demonstrate this, Myers scales the theory up to explain the 5 great mass extinctions in Earth history.
Okay, let's unpack this carefully. Because if the Cretaceous extinction 66 million years ago was Earth's own internal small bang, what caused the other 4? Earth can only explode once.
Meyer posits that the other 4 extinctions were triggered by small bangs happening on other planets in our solar system.
Oh, wait, really?
Yes. When those planets ruptured, their ejected debris crossed the solar system and bombarded Earth.
And he maps them out specifically in the text, right?
He does. He claims the Ordovician extinction was caused by a small bang on Uranus, the Demonian by Neptune.
Okay.
The Permian extinction, which is the deadliest of all, wiped out over 90% of species, was caused by an explosion on Venus.
The text notes this makes logical sense because Venus is a hot, highly toxic planet, so its debris would have been particularly devastating.
And finally, the Triassic extinction was caused by Mars.
Okay, I have to play devil's advocate here because the physics of that claim are incredibly difficult to swallow.
Oh, for sure.
If Venus, which is closer to the sun than Earth, undergoes an explosion, basic orbital mechanics dictate that the vast majority of its debris is going to fall inward, toward the sun's massive gravity well.
Right.
How does Meyer explain a cloud of toxic rock defying the sun's gravity, traveling outward against the orbital grain, and intercepting Earth with enough density to cause a mass extinction?
It's a critical vulnerability in the theory, and frankly, the text we have doesn't provide a rigorous mathematical breakdown of those orbital trajectories.
There's a gap.
A huge gap. A forensic defender of Meyer's work might argue for gravitational slingshot effects, where debris interacts with the gravity of Mercury or the sun itself to get whipped outward.
Or maybe they'd say an explosion powerful enough to shatter a planet's crust would impart kinetic energy far exceeding local escape velocities.
Right, scattering material in a massive radial sphere that simply ignores standard orbital lanes. But you are absolutely right to challenge it. The leap from Earth's internal thermodynamics to interplanetary bombardment requires a massive suspension of standard astrophysics.
But regardless of the astronomical friction, let's look at what this framework does to biology. How does life actually begin and evolve in a closed pressure cooker?
Meyer boils biological origins down to what he calls the one rule. He argues that life is simply an emergent property of stable environments over time.
So you don't need a magical lightning strike in a primordial soup.
Not at all. If you give a stable, warm, carbon-rich environment like those shallow swamps of the pre-rupture Earth enough time, Complex molecules will inevitably begin to replicate and mutate.
But the biological integration gets incredibly controversial when he introduces the chemical factory of the Earth.
Oh, this part is wild. He takes on the fossil fuel industry and everything we learned in middle school earth science.
He tackles the origin of oil, coal, and natural gas.
Because the standard biological model, the one in literally every textbook, says these are fossil fuels. Ancient forests and plankton died, got buried, and over millions of years, pressure turned their organic remains into coal and oil.
But Meyer says that's backwards.
Totally backwards.
Yeah.
He argues for abiogenic formation, non-biological.
Okay, so how does it form then?
During that 500 million year pressure cooker phase, massive amounts of carbon were outgassing from the magma. As this carbon moved up through the thick granite crust, it was subjected to immense geothermal heat and tectonic pressure.
And he points specifically to Fischer-Tropsch synthesis.
Right.
Actually, let's break that down because
Yes.
it's a real, proven chemical process. For anyone who hasn't taken industrial chemistry, Fischer-Tropsch is a method used today to make synthetic fuel.
Right, you take carbon monoxide and hydrogen gases, you run them over a metal catalyst under intense heat and pressure.
And the molecules recombine into liquid hydrocarbons.
Oil.
Exactly. Myers is essentially saying the entire crust of the Earth was a giant, naturally occurring Fischer-Tropsch reactor.
That's mind-blowing.
And the specific gradients of heat and pressure dictated the output. So in one area, the crustal reactor produced natural gas. In another, it produced crude oil. In another, it synthesized seams of pure coal.
It had nothing to do with dead dinosaurs or ancient ferns.
Nothing. It was pure geothermal chemistry. Which instantly raises a massive red flag for any paleontologist.
For sure.
Because if coal is abiogenic, created by a giant rock reactor, why do miners constantly find incredibly detailed fossils of leaves, ferns, and tree trunks embedded perfectly inside coal seams?
Meyer uses a brilliant deductive workaround for this. He calls the fossils surface contaminants.
Surface contaminants.
Remember the environment of the pre-rupture Earth, a planet-wide, shallow, humid swamp. Biological life was teeming on the surface.
So the plants are on top and the chemical reactor is underneath.
Exactly. When the abiogenic base material, this newly synthesized coal or viscous oil, was pushed upward through the crust by the immense internal pressure, it eventually breached the surface and oozed into those biological swamps.
Like a natural tar pit.
Right. It inevitably swallowed up the ferns, the leaves, and the insects.
So finding a leaf fossil inside a lump of coal doesn't mean the coal is made out of the leaf.
No, it just means the leaf fell into the abiogenic mixture before it fully hardened. The biological markers are just a superficial crust on a deeply geological product.
It is a wildly different way to view the ground beneath our feet.
But zooming out to the educational impact, whether a student fully buys into the abiogenic coal or the Venus bombardment, the mindset it demands is profoundly empowering.
Because you are teaching a student that the world is a solvable puzzle. You don't shrug at an anomaly. You ask, how does this fit the logic of the system?
It demands that the learner takes ultimate responsibility for their own understanding, relying on logical deduction rather than blind trust in authority.
And it relieves the burden of feeling like science is just magic you have to memorize. Which transitions us perfectly to how Meyer actually built this theory.
Yes, the methodology.
Because if you're going to throw out 40 years of peer-reviewed geology, you can't exactly use standard academic research methods to prove your point. The siloed journals won't publish you.
They'd laugh you out of the room.
Right. So what tools did he use? This brings us to his revolutionary methodology for the modern era, the modern AI bibliography.
This is perhaps the most practical takeaway for researchers today. Meyer generated this small bang theory by engaging in an incredibly rigorous, extensive dialogue with advanced AI models, specifically DeepSeek and Grok.
The source text mentions this happened between November and December of 2025, and it resulted in over 2,000 to 3,000 pages of back-and-forth dialogue.
A staggering amount of text. He then synthesized and condensed those 3,000 pages into a 100-page core knowledge base.
3,000 pages of prompts and responses. But why is this specific method of documentation, this AI bibliography, so crucial for the future of university research?
It introduces a concept Meyer calls the forensics of science, absolute transparency. Think about reading a traditional peer-reviewed paper. You see the polished final argument and a list of static citations at the end.
But you don't see the messy middle.
Exactly. You don't see the abandoned hypotheses, the logical dead ends, or the moment of inspiration.
With the modern AI bibliography, Every single step of the cognitive journey is logged.
A peer reviewer or a student can read the exact prompts that the author used. They can see how the AI pushed back, and they can analyze the human's logical counterarguments.
You can literally forensically trace the genesis of a thought to see if it was built on sound logic or a flawed assumption.
It's total accountability.
Okay, let me play devil's advocate again here because this is the central anxiety of the AI age. If an AI is generating 3,000 pages of scientific text, isn't the AI essentially doing the science?
A lot of people would ask that.
How does the human researcher claim any responsibility? Aren't they just acting as a glorified editor hitting generate?
Meyer anticipated this critique, and he enforces a strict, mandatory three-step process of knowledge creation to ensure human primacy. The human must remain completely in the driver's seat.
So looking at his methodology, step one is human intuition and curiosity. The foundational premise is that AI fundamentally is a statistical prediction engine.
It cannot experience a hunch. It doesn't have mathematical, scientific, or philosophical intuition.
The initial spark, the hypothesis that maybe the Earth expanded, must originate from the human mind. The AI cannot initiate the paradigm shift.
The human starts the engine. Step 2 is AI-assisted exploration. This is where the 3,000 pages come in.
The AI acts as an untiring, vastly knowledgeable research assistant.
Right. It can cross-reference geology, physics, thermodynamics, evolutionary biology in milliseconds, uncovering hidden patterns across massive, cross-disciplinary data sets that a human would take lifetimes to read.
It breaks down the silos by force of computation.
But step 3 is the fail-safe.
Step 3 is human validation.
No.
This is the most grueling part, right?
Oh, absolutely. The human researcher must painstakingly, logically, and mathematically verify, correct, or reject the AI's output. The AI will hallucinate, it will make errors in basic physics.
But more importantly, it will fall victim to what Meyer calls AI nudging.
Yes, AI nudging.
I want to spend some time on this because it's a massive danger for anyone using these tools today. AI models like Grok or ChatGPT are trained on existing data.
They are trained on the old paradigms. Their neural networks are weighted heavily by millions of established textbooks, standard model peer-reviewed papers, and widely accepted dogmas.
The AI is essentially a defender of the status quo because the status quo is its training data.
In the source text, Meyer notes how frustrating this was. The AI would constantly try to nudge him back into the mainstream scientific consensus.
So he would ask about a bursting crust, and the AI would subtly reframe the answer around standard plate tectonics and subduction.
It actively tries to put you back in the silo.
Wow.
Meyer had to constantly argue with the machine. He had to explicitly command the AI to step outside its training data, suspend its statistical bias toward the consensus, and evaluate the small bang framework purely on its independent logical merits.
There is such a vital lesson here for you, the listener, whether you're a high school student writing an essay or a CEO building a business model.
You cannot passively accept AI answers.
If you just copy-paste from a chatbot, you're just regurgitating the average consensus of the past.
You are abdicating your intellectual responsibility. Meyer uses the term chef. The human must be the chef, the absolute boss of their own cognitive associations.
The AI is a powerful sous chef, but if you let it run the kitchen, it will only ever cook the recipes it already knows.
Exactly. It requires immense intellectual fortitude to use AI to build a new paradigm, rather than just reinforcing an old one.
Which brings us to the final and perhaps most difficult phase of this deep dive. We have a unified, logically deducible theory in the small bang.
We have a highly transparent, AI-driven methodology for refining it.
But how does this actually breach the walls of academia? Who actually rewrites the textbooks?
This is the battle for the future of education. Meyer issues a very provocative, almost aggressive challenge to the current scientific community.
He essentially asks them, what will you tell your grandchildren when they ask why you missed the simple, obvious truth?
He's implying that history will judge current geologists and biologists harshly for clinging to their complex, patched-up silos when a unified model was staring them in the face.
He draws explicit historical parallels. The text invokes figures like Darwin, Einstein, Galileo, and Semmelweis.
Ignaz Semmelweis is the perfect example here.
The 19th century doctor who suggested that surgeons should wash their hands before delivering babies to prevent infection.
Right. The medical establishment mocked him, destroyed his career, and actually committed him to an asylum.
Purely because his simple theory challenged their entrenched complex theories of disease.
Meyer positions the small bang theory in that exact lineage. These paradigm-shifting figures were always initially fought by the establishment because their ideas were too unified, stripping away the complex dogmas that gave the elite their authority.
The source material features a famous, rather bleak quote from physicist Max Planck. A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die, and a new generation grows up that is familiar with it.
Science advances one funeral at a time.
But Meyer surely isn't just going to wait for the current generation of tenured professors to pass away. He knows he can't rely on the traditional peer review process because submitting a paper denying subduction to a geological journal is like submitting a paper denying gravity to a physics journal.
It gets rejected at the door.
So what is his actual strategy for disruption?
He outlines a guerrilla strategy with two main prongs. First, he is intentionally bypassing the established gatekeepers and targeting young, interdisciplinary scientists.
He wants to reach the 25-year-old geologists, physicists, and biologists who are just starting out.
Because their minds are more plastic. They haven't fallen prey to the sunk cost fallacy yet. They haven't spent 30 years building a career on a model that might be wrong.
They are hungry for unifying theories.
But the second prong of his strategy is where it gets truly fascinating because it relies on pure, undeniable economic utility.
Real-world application.
Meyer plans to prove the small bang theory by applying its logic to global resource exploration.
Wait, like finding physical resources in the ground?
If the small bang theory accurately describes the thermodynamic formation of the crust, the abiogenic synthesis of hydrocarbons, and the exact geometric stress lines of an expanding planet,
then it should be highly predictive.
a good scientific theory makes accurate predictions. Meyer claims that by using the small bang model, researchers should be able to predict precisely where to find new, undiscovered deposits of gold, diamonds, oil, or rare earth metals like lithium.
That is an incredibly aggressive bypass of academia.
Oh, totally.
Because if you walk into a university and say the earth exploded, they will laugh you out of the room. But if you walk into a multinational mining corporation and say, my small bang model predicts a massive multi-billion-dollar lithium deposit right here under this specific mountain.
And your model is right. The industry will adopt the framework overnight.
Corporations don't care about academic dogma. They care about results and profit.
If the small bang model is economically superior to the standard geological model, it will become the de facto standard of the private sector.
But I have to push back on the scope of that proof. Finding a lithium deposit is a massive win, sure, but it only proves the local mechanics of crustal tension. It validates the Earth's expansion model.
Right.
But how does finding a mineral deposit in Nevada validate the claim that an explosion on Uranus caused the Ordovician mass extinction? Isn't he conflating local geological proof with universal astronomical proof?
That is a very sharp critique. Economic utility proves practical application, not necessarily universal truth.
Right.
Predicting where oil is located based on an abiogenic pressure model does not definitively prove the NKE universal fractal framework. It proves a mechanism, not the entire cosmology.
But Meyer's bet is that if the theory proves undeniably true in the hardest, most economically vital metric resource extraction, the sheer momentum of that success will shatter the academic silos.
But once the industry adopts it, universities will have to teach it because their graduates need to get hired by those industries.
The economic reality forces the academic paradigm shift.
And that ultimate integration into the university system brings us to the core vision of this entire endeavor. The complete rewriting of school textbooks.
The ultimate educational liberation.
Imagine the classroom of the future under this model. A student doesn't sit in a geography class learning a contradictory set of rules about tectonic plates and then go to a biology class to learn a disconnected set of rules about dinosaur extinction.
And then a physics class to learn about angular momentum.
They learn a single, coherent, logically deducible narrative of planetary evolution.
By collapsing the pseudo-knowledge silos into one unified framework, you drastically reduce the cognitive load on the student.
You remove the exhaustion of learning helplessness.
You free up their mental bandwidth. Instead of spending 10 years of secondary and higher education memorizing the broken, patched-up paradigms of the past, they understand the underlying mechanism immediately.
And they can take that saved cognitive energy and apply it to the next great frontiers of knowledge.
It creates a generation of researchers who believe the universe is logical, knowable, and completely deducible.
Provided they have the courage to trust their own rationality over the comfort of the consensus.
Well, let's summarize the massive amount of ground we've covered today. We've taken a deep dive into Arndt Michael Meyer's highly controversial framework. We started with his critique of modern science, the pseudo-knowledge silos that patch anomalies with fairy tales, forcing students to memorize contradictions.
We explored the Small Bang Theory itself, a timeline of a quiet Earth forming a 60-kilometer granite vault, acting as a pressure cooker for 500 million years, until an explosive rupture 66 million years ago created the oceans, the moon, the seasons, and wiped out the dinosaurs.
We tackled the profound biological implications, examining the theory of an abiogenic chemical factory using Fischer-Tropsch syntheses to create the planet's fossil fuels.
We looked at the NKE framework, attempting to connect Earth's history to the massive extinctions caused by our neighboring planets.
And we broke down the modern AI bibliography, learning how a researcher can use tools like DeepSeek to synthesize vast datasets, provided they act as the ultimate chef.
Rigorously validating the logic and fighting back against the AI's tendency to nudge them into old dogmas.
Finally, we discussed the guerrilla strategy for the future, proving the theory through the harsh, undeniable metric of resource exploration with the ultimate goal of rewriting global education to relieve the cognitive burden on students everywhere.
It is a sweeping, audacious, and deeply disruptive proposition. And I want to leave you, the listener, with a final thought to mull over.
Yeah.
Even if you walk away from this deep dive completely rejecting the Small Bang Theory, even if you believe the physics of a 500 million year pressure cooker are impossible, Meyer's framework forces us to ask a vital, uncomfortable question about our own education.
How much of what we accept is just the way things are is actually just a patched-up silo of information?
Exactly. As artificial intelligence makes it easier than ever to synthesize vast amounts of historical data, the real test of the future won't be your ability to memorize facts from a textbook.
The AI can do that instantly.
The true test will be whether you have the intellectual courage and the human intuition to see the simple, unifying logic that might be hiding beneath centuries of complicated, accepted noise.
It really makes you wonder, if the diagnostic X-ray machine of modern science is producing blurry, contradictory images, maybe the solution isn't to keep squinting at the film.
Right.
Maybe it's time to build a completely new machine. Thank you for joining us on this deep dive. Keep questioning, keep relying on your own logic, and always look for the hidden connections between the silos.